Hi there. We talked in class about ways to model scenarios, written scenarios, with a graph. And so these 7 example problems were our notes in our practice. And so I'm going to work through a couple here for those who were absent or out of class for some reason, so you can potentially approach worksheet 6 with a little bit more of a knowledge base. Okay, so this first one here is 3 pounds of squid can be purchased at the market for $18. And so the first thing we want to ask ourselves is, what are our independent and our dependent quantities? Remembering that our independent would be the quantity that controls the change of the dependent. As the independent changes, the dependent has to follow suit. And so when I'm looking at this scenario here, 3 pounds of squid purchased at the market for $18, the two quantities that I see being measured are the amount of squid and your total cost. And so then the question is, well, which one determines the other? Our independent and dependent. And in this particular case, our independent would be the amount of squid purchased. And the reason that is the independent is because as that changes, as I purchase more squid, that specifically alters the total cost. The independent makes the dependent change. And so when it comes to graphing that, I'm going to come to my graph paper here, and I'm going to be plotting points. Okay, so here's my graph, x-y axis. My x-axis is the axis upon which I place the independent quantity, and so I'm going to go ahead and put amount of squid on my x-axis. And the y-axis is your dependent quantity. This is where I'm going to put total cost. And then I'm going to model this. When I've bought 0 pounds of squid, I will have paid $0. But as I slide over and I buy 3 pounds of squid, I'm now going to pay $18. Right? And at 6 pounds of squid, I'm going to pay $36. And so on and so forth. And so the graph that I see forming here is an increasing linear function. Right? As I buy more squid, I have to pay more. And so this is going to continue to increase. Okay. Another one, let's go ahead and take a look at number 3 here. Right, number 3 says, Luke throws a ball straight up into the air. After it reaches its maximum height of 30 feet, it descends back to the ground. And so again, we start with that same question. What are my independent and dependent quantities? Remember, your independent is the one that makes the dependent change. And so when I'm looking at this equation, or at this problem, I should say, Luke throws a ball straight up into the air after it reaches its maximum height of 30 feet, descends back to the ground. One thing that is being measured stands out really quickly, and that's the height of the ball. Right? In fact, we're even told it reaches a maximum height of 30 feet, so we are measuring height. And the other one's a little bit harder to see because it's not specifically addressed in this problem. And so you have to kind of use a little bit of imagination here. What other thing would be measured in this problem? What other thing could you be measuring if you watched someone throw a ball up into the air up to 30 feet and then it fell to the ground? Well, the other thing that's measured here is time. Right? How long did it take? When Luke first released the ball, it flew up to 30 feet and came back down and hit the ground. How much time passed? Okay? Time is our independent. Time happens. I like time because a lot of times time is your independent. Right? And so if I can see time in there, it usually preludes an easy problem, or at least an easier one, right? Because we can identify that time is our independent quantity. And so our dependent quantity here is going to be height. So let's go ahead and come to our graph. We're going to go ahead and graph our story graph. Remember, independent goes on the x-axis, so time is going to go down here. Dependent goes on the y-axis, height in feet. And then we have to imagine what would happen. At time t equals 0, where's my ball? Well, my ball would be sitting in Luke's hand, right? And so it would be maybe here. Okay. And then at time t equals 1, he would have released it, and it would be going up and up and up and up and up and up until it reached 30 feet. And then it would start falling again, and it would come down to the ground. And if you think about it, right, in fact, I might even challenge you, if you have trouble imagining it, pick up a ball and toss it into the air. And look at what kind of shape it makes. That ball would make this quadratic looking shape, right? It would arch into the air and then come back down. Okay. Let's go ahead and move over to number 5. Number 5 says, Corey and Rachel bought 30 ounces of popcorn at the movies. Retell their story on the graph to the right. Well, we're going to tell it on my own graph paper here. Okay. Hint, at 0 minutes, how much popcorn did they start with? Plot this point first. They did not eat any popcorn for the first 10 minutes as they were waiting for the movie to start. They began eating 2 ounces every minute for the first 5 minutes of the movie. Then Rachel left to buy some Milk Duds. Corey continued to eat the popcorn by herself at only 1 ounce per minute for the next 5 minutes. Rachel returned during a very, very scary scene. It startled Corey so much that she screamed and dropped the popcorn, spilling every last kernel. So again, same first question. What are my independent and dependent quantities? Well, the two things that I noticed getting measured here are time and ounces of popcorn. And I'm going to go ahead and make my dependent based on my story, ounces of popcorn in the bucket, because I was told here at the beginning, hint, at 0 minutes, how much popcorn did they start with? How much was in their bucket? And so I'm going to make that my dependent. How much is in the bucket? Independent is time. Again, we like time. A lot of times it's your independent. Time in minutes. And as it passes, that determines what's happening to the popcorn in the bucket. Okay. So there we go. Okay, I'm going to go ahead and graph this. Remember, x-axis is your independent, y-axis is your dependent. X-axis independent, y-axis dependent. And at time t equals 0, at 0 minutes, how much popcorn did they start with? They were up here at 30. Right? And for the first 10 minutes, they don't eat any popcorn. So for that first 10 minutes, there's the same amount of popcorn left in that bucket. But then they start to eat, and for the first 5 minutes, they are eating at 2 ounces per minute. And so the popcorn in the bucket's going to decrease. Then Rachel leaves to buy Milk Duds. Corey's still eating, but now she's only eating at 1 ounce per minute. So the popcorn's still decreasing, but it's not decreasing as quickly. And then finally, at the last point, Rachel returns, scares Corey so much that she screams and drops the popcorn, spilling every last kernel. And so in that moment, the popcorn would drop down to 0. Very suddenly. Okay. Number 7, last one we're going to do here. Just drawing story graphs, right? Just drawing the shape of the event that's taking place. The air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly again before dropping sharply. Okay, so what two things are being measured? Well, I notice hours, so time is getting measured, and I notice that temperature is getting measured. And depending on how many hours have passed, right, my temperature will have changed. Independent controls the dependent. Okay, so we're going to come here to our graph. Independent on x-axis, dependent on y-axis. So what happens at first? Well, the air temperature increases steadily for several hours. So my graph's going to go ahead and increase for several hours. It then remains constant. Well, constant is a flat line. At the end of the day, the temperature increased slightly again, so it's going to go up a little bit, before dropping sharply. And there's my story graph. It's a picture of the scenario described.